All right, welcome back, everybody. We're going to start the second set of notes here just so that we can kind of stay on pacing. And we're continuing to talk about experiments and building on our foundational knowledge of how to structure an experiment, kind of that flowchart idea. And we're going to get into some kind of interesting examples today of variations that you can do. So let's jump right in. We have a little bit of vocabulary to open us up here in the E2 notes. The first thing that we need to know is that all well-designed experiments attempt to give equal treatment to all the individuals. Now, you need to be a little careful with this. When I say the word treatment, I'm not actually talking about the experimental condition. I'm talking a little bit more about the experience that each individual would have. So you don't want people to be in one group treated very much differently than people in another group, unless that is literally the condition that you're testing. So the reason that this might be important is because it could introduce bias. It could maybe start to introduce the placebo effect even. People in the experiment should all be as similar as possible and go through basically the identical experience, except for that one thing that the researcher or the experimenter is changing, manipulating, to see if it has an impact on the end results. Treating some people in a group really, really well and then other people trashy is introducing kind of this lurking variable, unless that's the thing you're testing. So down below it says the logic of a randomized comparative experiment assumes that all the subjects are treated alike, except for the treatments that the experiment is specifically designed to compare. Any other unequal treatment can cause bias. But treating subjects exactly alike is really hard to do. So here are two methods that you can try in order to treat subjects the same. The first, make the experiment double-blind. What does double-blind mean? Well, it's when the subjects don't know what they're getting, and then even the people who are working with them don't know what treatment they're giving out. So this eliminates bias. A lot of times this is used in clinical trials when doctors are prescribing medicine. So if a doctor knows that a subject is receiving the placebo, he might not talk to them the same way as if he knew they were getting the real thing. So maybe he's more positive if he was giving out the real drug versus he doesn't say certain phrases, or his body language is kind of negative if they had the placebo. And so you don't want to introduce that possibility for bias. So the doctors wouldn't know. The pills would be, colored the same, or they'd come from a box that looks the same. And they would just be told by the experimenter, the people who oversee the whole thing, that, hey, you need to give this patient this medicine. And the doctor would follow that. They don't know whether it's the real thing or whether it's the placebo. Likewise, patients wouldn't know as well. So double-blind is very important to eliminate that potential bias. Second thing is make the experiment completely randomized in design. Allocate or split up the experimental subjects at random along the different treatments, and that eliminates the bias that comes from choosing. So we already knew that, but this double-blind style is maybe a little bit new to us, but it's used a lot in the real world. Even if you follow both of those things, sometimes errors still can occur. They can still happen. And so these are some types of common errors that you might deal with if you had to design your own experiment. The first one is refusals. Refusals are potential subjects who decline to participate in the experiment. Now, why is this bad? A lot of times bias can often occur because refusals might be systematically different than those who want to participate. So in past experiments, it could be a certain ethnic group or a certain cultural group who doesn't maybe trust the medical system. And so they would say, nah, not going to participate. And so then you wouldn't be able to see if your medicine works on that group. Maybe it works just fine, but maybe there are potential side effects or things like that that you just aren't observing because those people never enroll. They refuse. The next one is people who don't follow the rules. They're called non-adherers. So they are participating, but they aren't following the prescribed treatment. This causes bias towards that particular individual and the results. So if they're being told to do something and they are not, if in the end their data looks different, it might be because of that choice. And we don't want that. We want everybody to get as similar of a experience as everyone else. The last type of error that can sometimes happen is from dropouts. So not everyone who enrolls in an experiment finishes an experiment. If you have a longer time frame, an extended experiment, these subjects would introduce bias because why are they dropping out, or what would their results have been had you been able to gather data from them in the end. So you don't want those things, but they can happen. In your homework, make sure that you're bringing up or thinking about those different types of errors when you're arguing for why something might be constructed well or potentially not constructed very well. Let's go ahead and let's go down to the bottom of the notes here. We're going to talk about a style of mixing treatments that a lot of experiments use. So typically, an experiment isn't just testing one thing. A lot of times, in order to be a little bit more efficient, they group several things together, and they have methods for like separating them out at the end. Was this really the reason that we were seeing a change, or was that piece the reason for change? And so a lot of times we organize them a little differently. If we're interested in more than one variable, we sometimes use what's called a combination diagram, because it's going to show us the different combinations of treatments that people might go through. So you're going to see that this is a little bit of a grid. If you've taken science, you probably are familiar with Punnett squares, which shows the different combinations of genes that a child or an offspring might receive from their parents. And it's kind of similar to that. So we're going to look at this first example, and we're going to see how to construct a combination diagram. Number one, I hope that you guys remember that Physicians' Health study from the other video from earlier in the chapter. That Physicians' Health study studied if aspirin could help prevent heart attacks. And in fact, the PHS looked at the effect of two drugs, actually, aspirin and then beta-carotene. The body converts beta-carotene into vitamin A, which could maybe prevent some forms of cancer. Now, on odd number days, the subjects took a white tablet that contained either aspirin or a placebo. On even number days, they took a red capsule containing either beta-carotene or the placebo of beta-carotene. There were also several response variables that they were studying. They looked for heart attacks, different types of cancer, and other medical outcomes. So we're going to create a combination diagram below to show how the different explanatory variables combine to form these treatments. So the first thing that you're going to need to think about is how many variables are we testing? The really hard experiments, the really detailed experiments might go even past what we're going to do. So we just had two variables. We had beta-carotene, we had aspirin. So what we're going to make is a 2x2 grid. It's going to have two sides. And one of those sides is for our first variable. So that might be over here. The other side might be for our second variable. And you're going to see here that they're going to cross in certain ways. That's what makes it two-dimensional, makes it a grid. So after we know we have one variable on one side and another variable on the other side, we have to start to label and organize things. So we're going to go ahead and put aspirin in one of the rows. The placebo for aspirin goes in the other row. Then we have beta-carotene in this column, and we have beta-carotene's placebo in the other column. What this does is it starts to actually form our different treatments. We're going to have 4 treatments in this situation because of the different combinations of the two that we might potentially be giving out. And so how do they combine? Well, aspirin, beta-carotene actually go into treatment number 1. Aspirin continues over to this box, and the placebo is what they're getting on those alternating days. Aspirin one day, placebo the next. Aspirin one day, placebo the next. That way they know if there's a change in the end, it was just the aspirin, because on the other days they weren't taking anything. It was a placebo. It shouldn't have any effect at all. Now, if potentially the group that was receiving both of them did much better, then we would know that it's actually a combination of the two. It's not just aspirin, but it's when used in conjunction with beta-carotene. And so you kind of get this extra layer of potential results. You'll do the same thing on the bottom. You'll have a placebo with beta-carotene, and you'll have a placebo with a placebo. That is your ultimate control group. So they are not getting any active medication at all. They're just getting placebos on both days. So there shouldn't really be a change in that group. But we know sometimes that happens from the placebo effect. So we'll go ahead and we'll write in all the different options. Aspirin and beta-carotene, aspirin and placebo. Placebo and beta-carotene, placebo and placebo. And one other thing that was important for this, at least, was whether they took it on an odd day or an even day. And so you can kind of pair those up with when they would take them. Now, one thing that's kind of cool is that all 4 of those treatments, you could potentially diagram that. You could create a little sketch of what the experiment would look like. So if you want, this is kind of a little vision for where it would go. You'd start with your subjects, go to all 4 treatments, which we listed here in the table, and then we would gather the responses, the data, and analyze it in the end. So why do we do this? It's because maybe taking aspirin and beta-carotene together has an effect that just one or the other wouldn't have. And it could be a good effect or it could be a bad effect, okay? Just, is there a change caused by combining the two? And so we're able to study that a little bit better if we have a combination diagram, if we're combining 2 variables in this way. Hopefully that makes sense. We're going to try another question similar to this, and then we'll be done with this part of the video. Let's go ahead and let's flip to the next page. So problem number 2 on the next page asks, what are the effects of repeated exposure to advertising? We are subject to a lot of advertising. I'm sure that if you're on the internet, there are ads on websites that you visit. On Facebook, any social media, there are tons of ads. If you watch YouTube videos, there's usually an ad in front. But does that have an impact on, our perspective of things? Like, are we more likely to buy something that we see often? And Google is great at this. They are the advertising king. They understand, based on your search history and some data and things like that they collect, what type of ads you should see versus what type of ads I should see, because we're probably interested in different things. And so this has kind of gradually evolved over the years. It used to be everybody sees the same billboard, but now with the internet, this advertising idea is a lot more complex. And so the answer here, if there's an effect from advertising, might depend on the length of the ad and then how often you see the ad. An experiment investigated this question using some undergraduate students as subjects. All the subjects viewed a 40-minute television program that included ads for a digital camera. Some subjects saw a 30-second commercial. Others saw a 90-second commercial. That same commercial was repeated either 1, 3, or 5 times during the program. So you might see a short one or a long one, and they might just show it to you once, or a couple times, or a lot of times. And so we're going to see if we can mix those things together. After viewing, all the subjects answered questions about their recall of the ad. How was their attitude towards the camera, their intention to maybe purchase it, and so those are going to be the response variables, what we look at in the end. This experiment had 2 explanatory variables: the length of the commercial and then how many times it repeated. And there were 3 levels there. So if there were 2 levels for the length and 3 levels for the number of repetitions, the combination diagram is actually going to have 6 different cells. And you can kind of see that down below. That's how we would construct our combination diagram. So after we construct our grid, we're going to go ahead and put the 2 variables. First variable, how long the commercial is. Second variable, how many times it's repeated. We can go ahead and label the columns and the rows. So it would be 30 seconds versus 90 seconds. Those are the different lengths. And then the number of repetitions, 1 time, 3 times, 5 times. After we do that, we start to look at how many treatments we'll have in the end. 6 total. 2 times 3 is an easy way to get that. And then we start to fill in the combinations of those variables. 30-second ad, 1 time. If I'm in this experiment, I'm hoping I'm in that group. Then we have 30 seconds with 3 times, 30 seconds with 5 times. That's just getting annoying, but we've all been there. Then we have the second row, 90 seconds, really long commercials. Can't skip them. The worst. And this group only gets it once. This group gets it 3 times. And the poor souls in treatment number 6 have this extremely long commercial 5 times during the TV show. So I do not really want to be there. But we would get to see, does the length and does the number of times people view it kind of cause this outcome? Okay, at least for undergraduate students. Maybe not for old people, maybe not for young kids. They wouldn't be interested in camera. And so we have to be careful who we generalize our results to. Down below this, we're going to draw and label a sketch for the flow chart of this experiment, and this is the last thing we're doing. We can abbreviate each treatment since we have 6. We don't need to write them all here. So the first thing, we start our experimental flowchart with the subjects. Who were we studying? Hopefully, if you picked up in that paragraph, if you read closely, they're undergraduate students. So that would be after you graduate high school, your first 4 years of college. You are not a graduate student. You're not getting your doctorate or things like that. Okay, so these are kids who are 18 to probably 22, that neck of the woods. The second thing, where are they going? What are they having to go through? And we have 6 different treatments. So we'll block that in. Treatment number 1, 30 seconds one time, all the way out to treatment number 6, 90-second advertisements 5 times. So that just comes from our combination diagram up above. We take all of that information, and those groups come back, and we collect their data about how they felt. So they're going to answer some questions about their ad recall, like do they remember the ad? If you're in this group, you really remember the ad because you've seen it a lot, and it was really annoying, I'm sure. What was your attitude? Maybe some people were actually interested. Maybe others were not. And then their intention to maybe buy the camera after all of this. So combination diagrams give us this second layer, a way to compare multiple things at the same time. And you have to be very careful about how you organize it, so that way you can say with certainty what is really causing this response. Hopefully that makes sense. You guys don't have to start the homework yet. We aren't finished with the notes. When I see you guys next time, we will make sure to get those finished, and we'll go from there. Thanks for watching the video, guys. I hope you have a great night. Take care.